Hello class, today we're going to begin talking about inequalities. So this is the first part of a two-part video. In this video we will learn how to read and write and graph inequalities. Okay, so let's begin. As I said, in this particular lesson we're going to learn to read and write inequalities and then graph them on a number line. So we're going to learn some vocabulary inside this lesson. We're going to learn about what an inequality really is. We're going to learn the difference between an algebraic inequality and a numeric inequality. And we're going to talk about a solution set. We'll talk later about a compound inequality. So let's begin. An inequality states that two quantities either are not equal or may not be equal. That's very important to understand. Okay, because the thing that we've been doing is we've been talking about equalities or equations. Okay, so in an equation we have one answer, and that's the only answer that we have. In an inequality, we may have more than one. Okay, so an inequality again states that two quantities are either not equal or they may not be equal. And we use some signs to help us represent the inequalities. We use a symbol like this, and this symbol is called a less than symbol. Okay, we use one that looks like this, which we call as the greater than symbol. Okay, and sometimes those are very difficult to remember what they are. Okay, so you got to remember that if you look at the less than symbol, if I were to bend this little arm up, it actually turns into an L. So that's the less than symbol. So that's the one that we would call less than. The other one is the greater than symbol. Then we also have some of the same symbols, but we have a line underneath it. With this first one, it says that it's going to be less than or equal to. And the last one there is greater than or equal to. So that means it could be greater than or equal to the value in order to make a true statement. Now, this first part of the lesson is reading and writing inequalities. So we have some word phrases that can help us identify what type of an inequality we would want to use in our statement. So some phrases that represent less than are fewer than or below. Some word phrases that represent greater than are more than or above. Okay, less than or equal to would be at most or no more than, and is greater than or equal to at least or no less than. So that's by no means an exhaustive list of all the phrases that we could use, but that is a few of them that kind of help us identify. So let's see if we can do a few of these. Here's a couple inequality statements that I want us to see if we can write an inequality statement to match it. It says there are at least 15 people in the waiting room. So the first thing, in order to write an inequality statement, we must pick a variable. So since we're talking about people, I'm going to use the variable P to represent that. Then we're going to take the number that we have and we're going to write it down. Now I need to figure out what symbol goes in between this, because I want to know how many people could fit this situation. It says there are at least 15 people in the waiting room. Well, if we go back to our previous slide, we find out that at least means greater than or equal to. Okay, so that means that I would put a greater than or equal to. So the number of people in the waiting room would be greater than or equal to 15. So 15 happens to be what we call a minimum value, because it says at least 15 people. So there could be 15, there could be 16, there could be 20, but there's not going to be 14 or 13. Okay, because it wouldn't match what we call the solution set. Okay, B, the tram attendant will allow no more than 60 people on the tram. So again, we do the same thing. We're talking about people, so I'm going to use P as my variable. Okay, I'm going to put 60 down. And it says the tram attendant will allow no more than 60. Okay, so this 60 then becomes what we call a maximum number. Okay, so we can't have any more than 60 because it is too many. So that means this value here must be less than or equal to. And if we look back at our phrases, the no more kind of fits with, no more than. Okay, so there is our statement is less than or equal to. But 60 would actually work. Okay, so let me have you do a couple on your own. Okay, pause the video and answer these two questions. Write an inequality statement to represent each situation. Okay, let's see how you did. So A says, there are at most 10 gallons of gas in the tank. Okay, so I'm going to use G for my variable. I'm going to use 10 as my number. And the variable, it makes no difference as to which one you chose. I just chose G because it was about gallons or about gas. Okay, so it says there are at most 10 gallons of gas. Okay, so if we were to go back to our list, at most means less than or equal to. Okay, so less than or equal to. There is at most 10 gallons of gas, so that 10 becomes a maximum number. Okay, it's not going to be any more than that, but it could be 10. Okay, for B, there is at least 10 yards of fabric left. So we've got yards and we've got 10, and it says at least 10. So that means that we could have 10, but we could also have 11 or 12. Okay, so that means the Y is going to be greater than or equal to. Okay, so now this only showed the greater than or equal to or less than or equal to. So what if I change this first one to say that instead of saying there are at most 10 gallons of gas, what if I said there was less than 10 gallons of gas? Well, if there were less than 10 gallons of gas, then how would it change? Well, we would just have a less than symbol instead of a less than or equal to. If I said in the second one, there is at least 10 yards of fabric, what if I said there is more than 10 yards of fabric? Or there is greater than 10 yards of fabric? Then our inequality statement would just change to a greater than symbol. Okay, so there are phrases that represent greater than or equal to, less than or equal to, and phrases that mean just greater than or less than, where it doesn't include the value. It's going to be more than that. So what I'd like for you to do, I want you to pause the video, and I want you to write an inequality statement that would represent each of these 9 situations. Okay, so let's see how you did. Okay, on number 1, it says you need to score at least 30 points to take the lead. So the inequality statement you should have written is some letter, doesn't really matter what letter it is, I chose S for score, is greater than or equal to 30. Okay, so you've got to score at least 30. So if you scored 30, you would win. Okay, so number 2, there are less than 12 hours of daylight in each day, or each day in the winter. Okay, so there is less than 12 hours. So I would put light is less than 12. So since it's less than 12 hours is not going to fit into what we call the solution set. Okay, number 3, the bus seats at most 60 people. Well, at most means that 60 is a maximum number. Okay, so B is less than or equal to 60. Number 4, the coupon is good for any item that costs less than $10. Okay, so it's got to be less than $10 in order for the coupon to work. So that means coupon is less than $10. Okay, so if you had an item that was $10.05, the coupon wouldn't work then. Number 5, a score of at least 92 on the test is considered an A. So that means 92 or better would be an A. So score's got to be greater than or equal to 92. Number 6, the baby weighed more than 7 pounds at birth. So could they have weighed 7 pounds? No, they weighed more than 7 pounds. So weight is greater than 7. Number 7, Victor drives less than 12,000 miles per year. So that means the value's got to be smaller than 12,000. So miles is less than 12,000. Number 8, your waiting time will be 18 minutes or less. Okay, so could it be 18? Yes, it could, and it could be less than that. Okay, so T is less than or equal to 18. And then the last one, at least 15 students must sign up for the school trip. So 15 would work, it includes 15. So that's why we have an greater than or equal to on there. So that is the first part of understanding inequalities, is learning how to take a situation and create an inequality statement for that. Those will get tougher as we progress through the lessons. Okay? So now the next part of this lesson is how do I graph inequalities? Okay? Well, the first thing, let's understand the difference between an algebraic inequality and a numeric inequality. It says an inequality that contains a variable is known as an algebraic inequality. Okay, the value of the variable that makes the inequality true is a solution to the inequality. So all the ones that we just got through doing are what we call algebraic inequalities because they contain variables. Now, what's the difference between that and what we've done in the past? Well, if I were to give you a situation like -5, circle 7, this is known as a numeric inequality because what we're trying to do is figure out what type of an inequality symbol do I put in the circle. And we know that the 7 is greater, so we know that the inequality will open up to the 7, and we would read this as -5 is less than 7. This is a numeric inequality. Algebraic inequality is when we provide letters. Okay, so A is greater than 7. An inequality may have more than one solution. Very important to understand that. May have more than one solution. Together, all of the solutions are called a solution set. Okay, so we talked about sets earlier in the year called natural numbers or counting numbers or integers or whole numbers. Those are all sets of numbers. So in this particular instance, we will have a solution that will be a set of numbers. Well, you can graph the solutions of inequalities on a number line. If the variable is greater than or less than a number, then the number is indicated with an open circle, much like this first one right here. So this is the inequality statement right here. A is greater than 5. Okay, so I put an open circle on 5 because I need the values to be greater than 5, but it doesn't include 5. And all values greater than 5 are the ones to the right of it. So I put an open circle on 5 and I shade to the right, including the arrow, because the arrow means that the values continue to go. Okay, next one, if the variable is greater than or equal to or less than or equal to a number, that number is indicated with a closed circle because now we include that value. So here's our inequality statement. B is less than or equal to 3. Okay, because of the equal to, we're going to shade the 3 in. Okay, we're going to shade that 3 in. So we close the circle in and we shade to the left, which is all the values that are less than 3. So let's see if you can do one or two of these for me real quick before we end this video for today. Okay, so this one says I need to graph n is less than 3. Okay, so since it says less than 3, I'm going to put an open circle on 3 because it doesn't include 3. And I'm going to shade to the left because it is less than 3, including all the way to the arrow. Now for B, this one says I need A is greater than or equal to -4. Well, because it says equal to -4, I'm going to put a closed circle and I'm going to shade to the right because I need all values that are greater than -4. So let me have you do a couple by yourself. Pause the video and answer these two questions. Okay, let's see how you did. Now the A says P is less than or equal to 2. Okay, so I'm going to come over here and I'm going to put a circle on 2 and I'm going to shade it in. I'm going to close it up because it says equal to. Okay, and it says I need values that are less than 2, so those are the ones that are left of 2. Okay. For B, I've got E is greater than -2. So in this one, it does not include -2, so I put an open circle, but I need all values greater than -2. So what we've talked about in this lesson today is we've learned how to read and write inequalities, and we've learned how to graph them on a number line. In the next video, we will learn how to solve one-step inequalities. So until next time.